Good morning. Today is Wednesday, December 2nd, and our ICANN says I can identify prime and composite numbers using my divisibility rules. So we're going to start with a list of rules, and then we're going to practice using them. So here are the rules. These are very important. At first, they won't make much sense, but I promise after we start practicing with them, you'll understand what we mean. So here's the rule for 2. 2 is a factor if our number is even. If it's an even number, then we know that 2 is a factor. Even, again, means that it ends in 2, 4, 6, 8, or 0. So if our number ends in any of these numbers, we know that 2 is a factor. Okay. 3 is a factor if we add the digits together So you have to add the digits together all the way until you get a 1-digit number. So you keep adding and keep adding, add the digits together until you get 1 digit. If it is 3, 6, or 9, it works. 3 would be a factor. Okay, I'm going to do a couple of examples to show you this. That's a hard one and also one of our most important ones. So I'm going to list a couple numbers. I'm going to write 15. I'm going to write 36. I'm going to write 37. I'm going to write 87. Now here's how you test it. The rule says if we add the digits together all the way until we get a 1-digit number, if it equals 3, 6, or 9, then 3 will work. That proves that it's composite. These are the rules to prove our number is composite. What's 1 plus 5? 6. Did we say 3, 6, or 9? We sure did. So if I made a rainbow for this, 3 would be in the rainbow. Let's do 36. What's 3 plus 6? 9. Did we just say 3, 6, or 9? Yes, then we know that 3 works in this rainbow as well. And we just proved this number was also composite. So these are both composite numbers. What's 3 plus 7? It's 10. What's 1 plus 0? 1. Is that equal to 3, 6, or 9? No. So that does not prove my number's composite. This would be a prime number. What's 8 plus 7? 15. What's 1 plus 5? 6. Does that equal 3, 6, or 9? Yes, so we just proved that 87 is composite. That's how our 3 rule works. We'll come back to this. All right, 4 is a factor if the last 2 digits are divisible by 4. So 4 will work if you just look at the last 2 digits and if we can divide that by 4. So if I was looking at something like 12 divided by 4, well, I know that works because 12 divided by 4 is 3. But what if my number was 912 divided by 4? Well, instead of doing all of my math, I just have to look at the last 2 numbers. Is 12 divisible by 4? Yes. So 4 is a factor. What about 6,912 divided by 4? I don't know if it will work or it won't, but I can look at my last 2 numbers, and if 4 can go into 12, then I know this is divisible by 4. Now, it could be a different multiple of 4. It could end in a 16. It could end in a 36. It could end in anything that is a multiple of 4, okay? 5 is an easy one. Everybody picks up on this one really quick. 5 works if the number ends in 0 or 5. That's a great one. That means if it ends in 10, it works. Ends in 20, it works. 30, it works. 35 still works. It just has to end in a 0 or a 5. So 10, 15, 35, 45, 1,705. As long as it ends in a 5 or a 0, we know that 5 would work in the rainbow. 6 works if 2 and 3 are both factors. So if you've tested your rainbow and you've got 2 and 3 in the rainbow, then you know you're going to automatically have 6. I'll give you an example of that one. If I had the number 9 and I made my rainbow, I'd have 1 times 9 and 3 times 3. So I see 3, but do I have 2? No. And since I don't have 2 and 3, 6 won't work. But if I had a number like 18 and I made my rainbow, 1 times 18, 2 times 9, 3 times 6. Well, look at this. I have 2 and 3. So will I have 6? Yes. If you have 2 and 3 in your rainbow, then 6 will always be there. All right, so we've got 2, 3, 4, 5, 6. And lastly, we have 10. 10 works if it ends in 0. People usually like 10 and 5 the best. It's the easiest to remember. 10 works if it ends in a 0. 5 works if it ends in a 0 or a 5. Okay, so let's practice some. When would we ever have to use this? Well, we're going to do 3 practice problems together. Here's number 1. I'm going to list for you all of the numbers between 50 and 60. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. I made mine too big. Now, I want to use the rules that I wrote down on this page over here and see if I can cross off some of these numbers. So let's start. We know that 2 will work if our number is even. Is 50 even? Yes, so cross it off. We know that it's composite. We're trying to find how many primes are there. How many of these numbers are prime? All right, so we can cross off 50. Is 51 even? No, 1 is odd. 52 is even, so we know that's composite. 53 is odd. 54 is even, so that's composite. 55 is odd. 56 is even. 57 is odd. 58 is even. 59 is odd. And 60 is even. Let's cross those all off. All right, so look, I'm down to 5 numbers. It looks much better. So how many are prime? I know it's going to be 5 or less. All of these I've already proven are composite. Look back at your rules. Number 3, if we add the digits together all the way until we get a 1-digit number and it equals 3, 6, or 9. What's 5 plus 1? 5 plus 1 is 6. If I said 3, 6, or 9, we know that this is also composite, so we can cross that off. 5 plus 3 is 8. Well, that's not 3, 6, or 9. Let's leave this one there. 5 plus 5 is 10, and 1 plus 0 is 1. That's not 3, 6, or 9. Let's leave that one there. 5 plus 7 is 12. 1 plus 2 is 3. Did we just say 3, 6, or 9? Yes, so this one's definitely composite. What about 5 plus 9? That equals 14. 1 plus 4 is 5. Did I say 3, 6, or 9? No. So that could stay there. All right, right now I'm down to 3. How many primes? I think there are 3. Let's keep going. If the last 2 digits are divisible by 4, well, these aren't because they're all odd. Let's look at our 5 rule. If the number ends in a 0 or a 5, does this end in a 0 or a 5? Yes, let's cross that one off. That's definitely composite. I'm left with 2 numbers. So how many primes do I have? 2 primes. And my prime numbers are 53 and 59. And we're done. Let's try number 2. I'm going to list all of the numbers between 10 and 20. I'm going to write them closer together this time since I learned last time. Oh, I did so much better that time. Okay, I'm going to start looking at my rules. I have to start by crossing off a number if the number is even. So I'm looking at my numbers. Remember, even numbers end with 2, 4, 6, 8, or 0. Does this end? Is this an even number? Yes. Let's cross it off. It's composite. Is 11 even or odd? That's odd. Even or odd? It's even. We can cross that one off. 13, is that even or odd? It's odd. 14 is even. I bet you're picking up on a pattern. This was even, odd, even, odd, even, odd, even, odd, even, odd, even. Good. So I crossed off all of my evens because if it's an even number, we know that 2 is the only even prime. And we're looking for how many primes? Well, right now I know there have to be 5 or less because I just got rid of a lot. How many primes do I have? Well, there might be 5, but let's use the rest of our rules to find out for sure. All right, the 3's rule said add the digits together until we get a 1-digit number. 1 plus 1 is 2. Well, that doesn't equal 3, 6, or 9. 1 plus 3 is 4. That doesn't equal 3, 6, or 9. 1 plus 5 is 6. Did we say 3, 6, or 9? Sure did. Let's cross that one off. 1 plus 7 is 8. That doesn't equal 3, 6, or 9. 1 plus 9 is 10, and 1 plus 0 is 1. Is that 3, 6, or 9? No. All right, that's the 3's rule. If the last 2 numbers are divisible by 4, well, we know we won't have any of those because we already got rid of all of our evens. Number 5 says, if the number ends in a 0 or a 5, do any of my numbers end in a 0 or a 5? No. Guess what? We found all of our primes. How many primes are there? 4 prime numbers. So we have 4 primes and our numbers are 11, 13, 17, and 19. And this is what we're practicing. So why don't we do one last one? Here's number 3. I'm going to list between 20 and 30. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Okay. Look at your rule sheet. We're going to use these rules for every single one of these. If our number is even, we know that it's composite. So is 20 even? Yes, we can cross it off. Remember, there's a pattern. Even, odd, even, odd, even, odd, even, odd. I'm looking for all the numbers that end in 2, 4, 6, 8, or 0. All of those would be even numbers. The 0 numbers also would count for 10. It says if it ends in 0, this one ends in 0, and so does that one. All right, the next rule, let's go in order. If we add the digits together until we get a 1-digit number, and we say 3, 6, or 9, then we know it's composite. What is 2 plus 1? 3. Did I just say 3, 6, or 9? Yep, let's cross that one off. 2 plus 3 is 5. That doesn't equal 3, 6, or 9. 2 plus 5 is 7. That doesn't equal 3, 6, or 9. 2 plus 7 is 9. Did I just say 3, 6, or 9? Yes, let's cross that one off. 2 plus 9 is 11. 1 plus 1 is 2. Is that 3, 6, or 9? No. So look what I'm left with. I've got 3 numbers, and I'm trying to answer the question, how many primes? I don't stop too soon. A too fast 4th grader would stop right here and not use the 5 rule. The 5 rule says if the number ends in 0 or 5. 0 or 5? No. 0 or 5? Yes. 0 or 5? No. So this one we can cross off. It ended with a 5, so I know 5 would be in its rainbow. So how many primes do I have? 2 primes. And my primes are 23 and 29. All right, I think you guys are ready for some practice. Have a good day and use your notebook.